We're going to have a look at how to differentiate exponential functions. And first, let's be clear, we are not talking about e to the x. I know that the differential of e to the x is e to the x. I also know that the integral of e to the x is also e to the x, well, plus c, but I'm not going to quibble about that. Now, you might have wondered why that is true. And general teaching methods, or certainly one Dr. Frost uses, is like, okay, we'll work out the gradient, we'll show that it must exist at some point between 2.5 and 3, and then it just does, and it's a thing. You can actually use the method I'm going to show you, to prove this through actual differentiation. And it's also something that you can use for any exponential, and that's what we're kind of more interested in. We're not only going to be able to differentiate e to the x, we can differentiate 3 to the x, 40 million to the x, or whatever the hell it is you want to do to the x. So how are we going to do this thing? How can we achieve this? So your first line, we're going to start as y is a to the x, where a is some number. Remember I said this works for everything, so let's go with it. Now I'm going to use natural log on both sides. So natural log on both sides will give you ln y equals ln a to the x. And by applying laws of logs, that's the same thing as saying x ln a. Line below. This is the crunch line. And we're sort of going to hand wave this. As in, you don't actually at this point, you're not actually meant to at this point know that the differential of ln y is 1 over y. If you do want to know why that is true, it's basically reliance on the chain rule. I'm quite happy to prove that to people in another video if people want to know why that's true, but the differential of ln y is 1 over y. That's also, incidentally, why if you remember your integration questions early on, you're never asked to integrate anything x to the power of minus 1, because it doesn't work like anything else. It doesn't become x to the power of 0, and that's always a trick question I love playing on my students. I stick an x to the minus 1, can you do this? They all think they can. No, you can't. The integral of x to the minus 1 is ln y. That's for ln x, what am I saying? So you're just going to have to take that one on trust unless you really desperately want to see it, in which case put a comment in and I'll do it for you. But in any case, the differential of ln anything is 1 over the anything. So ln y differentiates to 1 over y. Now, the other side, if you differentiate x ln a is just a number, yeah? Natural log of whatever the number is times x. So when you differentiate that, the x vanishes, just as it does, so 3x differentiates to make 3, and all you're left with was ln a, okay? Now what have I done? I've got 1 over y, dy dx ln a. Now you might be thinking, why the hell dy dx as well? Okay, here's a little bit of kind of bump for the future. If you differentiate y anywhere, you have to have a dy dx, okay? There are reasons for this. Again, it's a bit annoying that I can't really tell you them. It's not really in the scope of this video. It's something called implicit differentiation for those uber keenies among you, or if you do further math, you probably know this already. But yeah, if you differentiate y, we have to keep the dy dx there. That's convenient, actually, in this case, because all I'm going to do now is times both sides by y. And I've got dy dx equals y ln a. Great. But we know what y is. So dy dx is literally just ax ln a. Right? Now, I appreciate a lot of that was hand-waving. It's like, okay, differential of ln y is 1 over y. We'll have a dy dx, y, because I said so. That's because the mathematics you need is actually taught next year for that. So I'm just going to say, either you buy it, or you come and attack me physically and say, prove these things. I'm quite happy to do it if you really want to, but that's how that works. Upside of this, once you know the result, you don't ever need to bother with it until, well, not until next year anyways. So if you want to differentiate y equals 6 to the x, the answer is going to be 6 to the x ln 6. You can just use the result, is what I'm saying. Now, integration is often referred to as anti-differentiation. It's the opposite process. So all you need to do is think to yourself, well, okay, what would I differentiate to get a to the x? And that is the thing that you'd get if you integrate a to the x. I know that sounds, I made a mouthful of that. Oops, sorry. I made a mouthful of that. But really, just think about integration as the opposite process to integration. So differentiation is the opposite process to integration and vice versa. So if you look on the right hand side of the question underneath integrate, if I differentiate a to the x over ln a, I'd get a to the x ln a over ln a, and the ln a's would just cancel and you just get a to the x again. So it follows that if I integrate a to the x, going back the other way, then I'd get a to the x ln a, and that's literally what the formula is. We're disregarding just plus c for the minute, but it should be there because it's indefinite integral. Again, even if you don't buy the logic, and I think this one, the logic does make a lot more sense. If differentiation works by timesing by ln a, integration works by dividing by ln a, I think that's pretty self-explanatory. you can still just use the method. So if I had to integrate, I don't know, 7 to the x, it's going to be 7 to the x over ln 7 plus c. So there's that. Here's one for you to try, and feel free to kind of have a go at me in the comments if you insist. Try differentiating it when it's got a number in front. See how that works. You should remember, hopefully, how that works for e. Obviously, this isn't e. I'm not asking you about e. So if you differentiate e to the 3x, you get 3e to the 3x. And if you integrate e to the 3x, it's 1/3 e to the 3x plus c. And the logic that made that true will help you while you're trying that. Okay? This is all very much kind of like extension work, but hey, I get tired of explaining the obvious every single time, so I'm going to basically not explain the obvious quite badly here. I hope at least the results make sense. I am a bit annoyed at the fact that I can't tell you all the stuff I kind of want to tell you on this, because it goes beyond the scope of this particular topic at this level. I don't know why they decided to parcel this here in this year's stuff, but here you go. You've got the results at least. And we'll have fun with chain and product rule next year, hopefully, if I'm lucky enough to teach the people I've got. If not, I'll be sad. Bye.